you might want to have your reference chart and or unit circle out because we will be referring to those just a little bit. But in Lesson 5.3, we are learning a new set of identities. Now, as some of you have heard, I think you'll enjoy today a little bit more. Okay, I mean, yes, there's work to do, but overall it's definitely gives some of you the break you need right now, I think, from what we've been doing. So we are learning the sum or difference identities. So we have three different sum or difference identities. There's an identity for sine, for cosine, and tangent. And I'm not going to spend much time up here. I'm going to more want to get into the examples and show you what the examples are doing. But the idea here is sine of x plus or minus y. So if we have two values being either added or subtracted together, we can find what it is equal to by doing sine of x, cosine y, plus or minus cosine x, sine y. Now, the reason this says plus or minus, the idea here is if they give you a plus here, in this case, it's also a plus over here. If it's a minus here that we're working with, then when we set this part up, it's a minus here. Okay, so that's a little bit of what we're doing here. And the idea of what we're going to do this is when we get down to example 1 here in a moment, we're being asked to find the exact value of cosine of 15 degrees without a calculator. So you're not allowed to pick up the calculator and just type in cosine of 15 degrees and give me an answer. That's not the answer I want. I want an exact value. And so these identities are going to allow me to do this. We have a cosine. The cosine, now notice something here. It's cosine of x plus or minus y. And then over here, it's cosine x, cosine y. Notice this is upside down. It's minus plus sine x, sine y. And what I want to point out to you here, it's plus minus here, minus plus here. Basically what that's saying is if you have a plus in this part of the problem, then over here it's the opposite sign and it's a minus. If you have a minus over here, then it's a plus over here. Okay, so when they reverse that sign and put upside down, that's what we're looking at. And then we also have a tangent. The tangent one is a fraction here. Notice it's plus minus here, plus minus on top, which means you're using the same sign on top, minus plus on bottom, which means you would be using the opposite sign. And that will make a little bit more sense once we get into an example. Okay? So, we're going to jump in here. And let's look at example 1. It's asking me to find the exact value of cosine of 15 degrees without using a calculator. Is cosine of 15 degrees on our chart that we've been using? No, what does our chart have on it? Our chart has 30 degrees, 45 degrees, 60 degrees. 15 degrees isn't on there. So this is where the sum and difference identities can come into play. How can we make 15 out of some of those numbers? Don't think about division, think about adding and subtracting. How can we make 15 out of a couple of those numbers? So we're going to do this is a cosine of a sum or a difference. In order to do the cosine of 15, I need two numbers that either add or subtract to be 15. But I want to pick numbers that I know the cosine and sine values of. So do we have two numbers in our chart that add or subtract to be 15? What's an option? 45 minus 30? 45 minus 30 is 15, yes? And that's the one I'm going to go with. Now, technically, is there a second option? Technically, what's 60 minus 45? It's also 15, isn't it? So you could technically use either option. It doesn't matter. It's whatever your eyes see. But what I'm going to do is I'm going to rewrite this. Cosine of 15 degrees is equivalent to saying cosine of 45 degrees minus 30 degrees. Can you agree? That's equivalent? I haven't changed anything, have I? I just rewrote 15 as 45 minus 30. So now, our job is to use the identity up above. And when using the identity up above, the idea is it's cosine of x plus or minus y. Well, our x value is going to be 45. Our y value is going to be 30. So every place I see an x in my identity, I'm going to put 45. Every place I see a y, I'm going to put 30. So, follow what it says up here. Cosine x, cosine y. So that means I'm going to write cosine of 45 degrees times cosine of 30 degrees. Okay, what about my sign? Do I need plus or minus here? We were given a minus to begin with. So with the cosine identity, I need to use a plus sign. Because remember, in the cosine, it's plus minus here, it's minus plus here. So that's telling you use the opposite sign. So we're going to say plus, and then it's sine x, sine y. So I'm going to say sine of 45 degrees times sine of 30 degrees. Now, the whole point of using numbers from our chart is that we know all this information. What is the cosine of 45 degrees according to our chart? Square root of 2 over 2. What is the cosine of 30 degrees according to our chart? Square root of 3 over 2. Plus, okay, what's sine of 45 according to our chart? Square root of 2 over 2. And you will notice I use the rationalized versions for what we're doing here. It just makes it easier to finish it up. And what is the sine of 30? 1 over 2. Clean it up. And we're pretty much done. So what is the square root of 2 over 2 times the square root of 3 over 2? Square root of 6 over 4. Square root of 2 times square root of 3. Square root of 6. 2 times 2 is 4. Plus square root of 2 over 2 times 1 over 2 is going to be square root of 2 over 4. Now, generally when you see these answers in the answer key, they go one more step and put them as a one fraction. Notice they already have a common denominator, yes? Denominator is 4. And then what's square root of 6 plus square root of 2? Square root of 6 plus square root of 2. So the answer for a problem like this that you would see on the answer key would be square root of 6 plus square root of 2 all over 4. Now, you're using the identity, okay? And 1 through 10 in homework, I believe, are just doing this type of thing, using the identity. Now, it said without a calculator, yes? But here's my thing, and this is more just a check. We didn't use a calculator to do the problem. Hold on, I got to change my mode back to degrees. If I find out that the cosine of 15 degrees, according to my calculator, is this lovely decimal, what would be a check for this? How can I check my answer? Yeah, let's check this answer we got here. The square root of 6 plus the square root of 2 all over 4 should equal what? The same thing as cosine of 15 degrees. It did according to my calculator. Notice, are my answers the same? They're identical, aren't they? Okay, and I'm not saying you need to do that. Okay, I mean, obviously, if you give me the answer of 0.9659, I'm counting it wrong because that's, you know, I'm not looking for the decimal answer here, am I? I am specifically looking for the exact value. And the exact value is not what your calculator gives you. The exact value is this, using the square roots, the fractions, and such. Questions on this one? Okay. Hopefully we'll have time at the end. 1 through 10 are doing this. Okay. The hard part of 1 through 10 is like half of them are in terms of radians. That's probably the hardest part of the homework, is that you have some of that are in terms of radians instead of degrees. And yes, you need to work them in radians. And so hopefully I'll have time to come back and talk about one in the end that's in radians to give you guys an idea. Okay, that's what I was able to do in the morning class. I came back, we talked about one, and that gave us, you know, we did one from homework. Okay, ready for the even easier stuff? Yes, it gets easier in example 2. Not more difficult, it gets easier. Okay, write each of the following expressions as the sine or cosine of an angle. So your answer is going to be sine of blank, or cosine of blank, or tangent of blank. It just doesn't say that in the directions. So as you look at sine of 22 degrees, cosine of 13 degrees, plus cosine 22 degrees, sine of 13 degrees. Don't grab a calculator. I don't want a calculator. Start comparing that to our identities up above. What do you notice? It's similar to the sine identity, isn't it? Okay, so right there, notice it's a sine, cosine, cosine, sine, isn't it? So right there, what I know is this is going to be sine of some number. Now, as we start going through and identifying, what do you notice? It's supposed to be sine x cosine y. So that means 22 is the x value. 13 is the y value. And then it's supposed to be cosine x sine y. Notice, 22 is still x. 13 is still y. So this is going to be the sine. It's x plus or minus y. So what are my x and y? 22 degrees and 13 degrees. What you have to decide, is it 22 plus 13 or 22 minus 13? Why would it be plus?
Because with the sine identity, whatever your sine was in the equation is the same that the sine was in the parentheses.
Okay. What she said. In the sine identity, it's plus minus, plus minus. That means the sign stays the same. So since it started with a plus sign, it's still a plus sign over here. Clean this up to give me a final answer. What is 22 plus 13? 35. So my answer is the sine of 35 degrees. I don't want to know what the sine of 35 degrees is. I just want sine of 35 degrees. Easy enough? Okay, shall we try B? What do you notice about B? It's cosine, cosine, plus sine, sine, which matches up with the form of a cosine identity, yes? Okay. Can you identify your x and y values?
X is pi over 3 and y is pi over 3.
Yeah. X is pi over 3, y is pi over 4. So that means this is going to be cosine of pi over 3 and pi over 4. Am I adding or subtracting that pi over 3 and pi over 4? She says subtracting. If you go back up and look at the cosine identity, with the cosine, it's plus minus here, minus plus here. That's the way of saying opposite signs. So, since we are provided a plus, we're going to use a minus. Now, okay, unfortunately this gets a teensy bit harder for a moment. We actually have to subtract those. How do we subtract fractions? Common denominator, yes? So we have to think common denominator. What is a common denominator between 3 and 4? 12. So we're going to do this in terms of twelfths. In order to get from 3 to 12, you multiply by 4. So 4 times pi is going to make this 4 pi over 12. In order to get from 4 to 12, we multiply by 3. 3 times pi is going to be 3 pi. So we are doing the cosine of 4 pi over 12 minus 3 pi over 12. And what is 4 pi over 12 minus 3 pi over 12? Pi over 12. So final answer, cosine of pi over 12. Please remember, if they give you degrees, you can finish in degrees. If they give you radians, you should finish in radians. Okay, you ready for C? Sine x, sine 2x, minus cosine x, cosine 2x. Thoughts on this one? Okay, so is it a sine identity or a cosine identity? Okay, I like that description, a tricky cosine identity. That is exactly what it is. A traditional cosine identity is listed as cosine, cosine, sine, sine. Which, if that was a plus sign in the middle, it would be a piece of cake. Okay, it is slightly tricky with that minus sign in the middle. So, there's a couple of different ways we can think about this. I'm going to flip-flop this. And if I flip-flop this, it is negative cosine x, cosine 2x. And then it is plus sine x, sine 2x. So we can see that it's a cosine identity, but in the cosine identity, what's the issue here? The cosine identity doesn't allow for a negative out front, does it? So my suggestion is that we factor a negative out. Okay, so if we factor a negative out front, and we'll just carry that along, then this negative cosine stuff becomes positive cosine x, cosine 2x, and plus sine x, sine 2x becomes minus sine x, sine 2x. Is that better for you? So that negative out front, I can just carry down. This is what type of identity? We already agree it's a cosine identity. What are my quote x and y values? X and 2x, right? So it's going to be x and 2x. Am I adding or subtracting x and 2x? What? Because when I rewrote this cosine minus sine, traditional cosine now, so opposite, and so that is a plus. Clean it up and you've got your final answer. This is going to be the negative of cosine of 3x. Okay. That was tricky, but I don't think it was horrible, was it? We've seen a lot worse in this chapter. I mean, just, this is nothing compared to the rest of the chapter. Okay, D. Officially, the directions say write it with sine or cosine, but what is this one, obviously? This is a tangent, isn't it? So, bring it down here. It's obviously in a tangent setup. What are my x and y values? 22 and 23. So the tangent of 22 degrees and 23 degrees, and you're subtracting. It is adding. If you remember, it was plus minus in the problem and plus minus on top. So you're going with the sign that it uses on top, and it should be the opposite of the sign in bottom. And what do you know about tangent of 22 plus 23? Tangent of 45 degrees. Someone this morning said, well, can't we put 1? Which I guess you could, but the whole point is just to get it to be sine, cosine, or tangent of something. Yes, technically tangent of 45 degrees is 1, but not what I'm concerned about there. Okay, you like that section? Okay. Well, it's this, if you go back up to the tangent identity up here, the tangent identity is that fraction. Tangent of x plus y, so tangent of 22 plus 23, is equal to tangent of x plus y, so tangent of 22 plus tangent of 23, over 1 minus tangent x, tangent y, tangent 22, tangent 23. Okay? Yeah. It's not that we were just doing the top parts. That whole fraction is our tangent identity. Okay. Example 3 is really just kind of a variation on the part of, a combination of the two parts above. It's not bad. Simplify each of the following. Sine of x plus pi. Now, obviously we can't add x and pi. And the whole point of today is to use these identities. So, let's write this out. Sine of x plus pi, according to our sine identity above, is going to read what? It's sine, so we're going to say sine x cosine y. What are x and y? Yeah, x, which x is x, that's good. And then y is pi. So if it's sine x cosine y, it's going to be sine x cosine pi. It was a plus sign in the middle. What do I use with the sine identity? Keep the same sign. And now it's cosine x sine y. So cosine x sine of pi. Okay. Sine of x, cosine of x. X is a variable. Can't really do anything, can I? But what about pi? Did you grab your unit circle out when you got your chart out today? Do we know anything about the cosine and sine of pi? Okay, here at pi, remember an ordered pair is cosine, sine, right? So the cosine of pi is -1. The sine of pi is 0. We need to sub those values in. So, sine x is going to stay sine x. Times, what did we just say the cosine of pi was? Negative 1. Plus, cosine x stays cosine x. What do we just say the sine of pi is? 0. What does that clean up to be? Cosine x times 0 is going to be 0. Sine x times negative 1. Negative sine x. That wasn't horrible, was it? Questions on that before we do B? Okay, let's try B. Cosine x plus 3 pi over 2. You follow the same type problem. Cosine identity, first of all, make sure you know your x and y. So, with the cosine identity, it starts off cosine, cosine. So cosine x times cosine of 3 pi over 2. What about a plus minus sign here? It's minus because the cosine identity uses the opposite sign. And then it's sine, sine. So sine x, sine 3 pi over 2. Okay, well, what do we need to know this time? Cosine and sine of 3 pi over 2. You got your unit circle? There's 3 pi over 2. Cosine? Sine. Yeah, so cosine is 0, sine is negative 1. So fill it in and clean it up. Cosine of x times cosine of 3 pi over 2 we decide was 0 minus sine of x times sine of 3 pi over 2 was negative 1. Well, cosine x times 0 again is cosine x times 0 is 0. And then it's minus sine x times negative 1. Positive sine x. Okay. And C. Last official problem of the homework. As I said, if I have a chance, I'll try and grab one of them from 1 through 10 and do one of those with you to get you guys started. Tangent of theta minus, that says pi over 4. Okay? So, you got your x and y identified? Tangent identity looks a little ugly, but it's not that bad. Tangent identity, it's going to be tangent x plus or minus tangent y. So in this case, tangent theta, tangent pi over 4, is it plus or minus? It's minus on top because the top uses the same sign as the original problem. Denominator, 1 plus, we use the opposite sign here, tangent x, tangent y. So tangent theta, tangent pi over 4. Okay. What's the one thing you can clean up here? Do we know tangent of pi over 4? Tangent of pi over 4 is 1 according to our chart. So, tangent theta minus 1 over 1 plus tangent theta times 1. And in terms of cleanup there, thank you. The only cleanup we can really do is tangent theta times 1, which you may not have even written that times 1 once you realized. So my numerator is going to be tangent theta minus 1. In the denominator, you could say 1 plus tangent theta, or you could say tangent theta plus 1. We can't really change the numerator around, but we could change the denominator around if you wanted to. Okay. 1 through 10 are a lot like example 1 on here. Okay. 11 through 22 are a lot more like kind of the middle section, maybe a little bit of the bottom section thrown in. Okay, so homework shouldn't be too bad. Now, I will be upfront with you. The hardest part is that on 1 through 10, there's radians in there. Okay? You want to go over any radians example with me real quick? I think, let me grab my pre-cal book. I think I did number 6 for homework in my morning class. So whether you want to put it in your notes or whether you want to go ahead and start your homework page, I don't care. But I was going to give you a little helpful hints to get started here. Yeah, I believe it was number 6 we did this morning, which is sine of 7 pi over 2. I'm going to come on the back of my notes here. When we did the very first homework problem on the front of the notes, right? Or the very first notes problem. It was cosine of 15, and that was a piece of cake because 45 minus 30 is 15 once I got you there, right? Now, when you go and look at 6 through 10 are all radians, and they all have denominators of 12ths. But yet, what do we have in our chart? We have, why did I write these back upside down? That's going to bug me. I can't handle that. Got to be honest. And maybe you guys don't care. I mean, it's not that it really matters, to be honest. But in our chart, we have pi over 6, pi over 4, and pi over 3, correct? Now, what do you notice about all those denominators? 6, 4, and 3 can all become what? Can't they all become 12ths? So here's what I would do on the side of your paper is I would list these in terms of 12ths. That way you have the visual. Because you're going to need to use these, but you're going to have to think in terms of 12ths. So what is pi over 6 in terms of 12ths? If you multiply by 2, it's 2 pi over 12. Pi over 4, what is this in terms of 12ths? Multiply by 3, 3 pi over 12. Pi over 3, you're multiplying by 4, and that is 4 pi over 12. Those are your basic 3 angles that you'll use, all from quadrant 1. I think there's at least one that's a tricky one that you have to go to quadrant 2, but that's a topic for tomorrow, not today. Okay? Here's my deal, guys. Sine of 7 pi over 12. How can I use 2 of these to get 7 pi over 12? Yeah, can't we add 3 pi over 12 plus 4 pi over 12? Okay, so let's write that in. 3 pi over 12 plus 4 pi over 12. Now, to be honest, when we actually go to do the problem, Are we going to think in terms of 3/12 and 4/12? Probably not, because those aren't on our chart. So as soon as you figure out which ones to use, I would go ahead and reduce those. And so I would think of this as sine of 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. I would think of it like that. I just use the 12ths to help me figure out which two do I need and how do I use them. Can you write out your sign identity now? How's our sign identity work? Sine x cosine y, so that's going to be sine pi over 4 cosine pi over 3. Is it plus or minus in this identity? Sign stays the same, so plus. And then it's cosine x sine y. Do you remember what to do from here? The chart, right? What is sine of pi over 4? Square root of 2 over 2. What is cosine of pi over 3? One half. Plus, what is cosine of pi over 4? Square root of 2 over 2. And what is sine of pi over 3? Square root of 3 over 2. Is this similar to what we already did in the notes? Very much so. Multiply. So we're going to have square root of 2 over 4 plus square root of 6 over 4. And if I put that together as one fraction, square root of 2 plus square root of 6 all over 4. And you now have one less problem of homework to do. Correct.
And then it would just be like,
no, it would be like, if you were adding square root of 2 plus square root of 2, think of it as 1 square root of 2 plus 1 square root of 2, which makes it 2 square root of 2. You add the coefficients out in front of the radical. So, okay guys, your homework, page 425, 1 through 22. Okay? There will be some issues we'll have to talk about tomorrow. For instance, how do you get 11 pi over 12? You know, it's not going to happen here, so we'll have to talk about how to use second quadrant angles. But hopefully you guys got some idea of what to do here. Homework is due tomorrow.